When Earth faces the potential penetration of its surface by solar radiation and cosmic rays, a formidable magnetic field emanating from the planet's outer core serves as a protective shield, deflecting harmful space energy. This phenomenon is referred to as the magnetosphere. Scientific understanding acknowledges that the internal forces generating Earth's magnetic field can undergo changes, causing fluctuations in the field's strength over time. Consequently, there can be gradual alterations in the intensity and position of Earth's magnetic north and south poles, and in some cases, a complete reversal where the magnetic poles trade places. Speculation has arisen about the role of these geomagnetic events in influencing extreme weather, triggering extinction events, or even causing disasters. Online assertions connecting Earth's magnetic field to climate change abound, but scientists dismiss these claims as lacking merit. Gavin Schmidt, a climatologist and director of the NASA Goddard Institute for Space Studies in New York, asserts, at this time, there aren't any credible mechanisms that could make it a possibility. It's not that we're ruling out magnetic effects on climate without thinking about it. We collectively have thought about it, and it's been found wanting. Earth has three distinct north poles: true north, geomagnetic north, and magnetic north. True north is a fixed point on the globe that aligns directly with the geographic North Pole. On the other hand, geomagnetic north, presently situated above Canada's Ellesmere Island, is not stationary. It signifies the northern axis of Earth's magnetosphere and undergoes periodic shifts. Magnetic north corresponds to the lines of the magnetic field and is the point your compass points to. Since its initial identification by Arctic explorer James Clark Ross in 1831, Earth's magnetic North Pole has migrated 600 miles north-northwest. Additionally, its speed of movement has accelerated from approximately 10 miles per year to about 34 miles per year, as explained by Alan Biz in a 2021 blog for Ask NASA Climate. Despite these changes potentially affecting satellites and magnetic-based navigation, ranging from cell phones to ships and commercial airlines, there is no evidence to suggest that these shifts influence Earth's climate. Nonetheless, the Adam and Eve story, a conspiracy theory linking climate change impacts to shifts in Earth's magnetic field, is experiencing a resurgence, particularly on Instagram and TikTok. This theory gained renewed attention after being featured on a January 2023 episode of The Joe Rogan Experience. Media Matters, a media watchdog group, identified 7 viral clips from the January episode discussing the conspiracy theory, amassing millions of views on TikTok between January and April 2023. The unfounded theory originated in 1965 when Chan Thomas, a former U.S. Air Force employee, proposed that magnetic pole reversals were responsible for the extinction of ancient civilizations. Thomas claimed that the initial flood occurred with Adam and Eve, followed by Noah and the Ark, and asserted that the third event is yet to be observed. Geomagnetic excursions represent significant yet brief fluctuations in magnetic field intensity, spanning from a few centuries to thousands of years, as outlined by NASA. The most recent major excursion, the Loschamps excursion, occurred approximately 41,500 years ago. During this event, Earth's magnetic field experienced a rapid weakening, leading to a reversal of the poles, only to return to their original orientation 500 years later. In a 2021 study, researchers proposed a connection between the Loschamps excursion and climate disruptions, extinction events, and shifts in human behavior. The hypothesis posited that during a period of weakened magnetic field, heightened solar and cosmic radiation could penetrate Earth's atmosphere, causing changes in ozone levels and driving global climate variations and extinctions. However, Gavin Schmidt expresses skepticism about this study, considering it speculative. He questions, where is the evidence for any changes in climate 42,000 years ago that are associated with extinctions? There are no shifts in the ice cores. We know that there was a lot of climate variability over the last ice age, and we have it pretty well timed. None of it lines up with this magnetic excursion. Over the last 70,000 years, 3 noteworthy magnetic field excursions have occurred: the Norwegian Greenland Sea event roughly 64,000 years ago, the Loschamps event spanning from 42,000 to 41,000 years ago, and the Mono Lake event taking place around 34,500 years ago. According to Biz, the crucial point to note is that there's no evidence that Earth's climate has been significantly impacted by the last 3 magnetic field excursions, nor by any excursion event within at least the last 2.8 million years. In the event of a pole reversal, Earth undergoes a swapping of its magnetic north and south poles. This phenomenon, which occurs approximately every 300,000 years on average, last transpired about 780,000 years ago, as reported by NASA. Over Earth's geologic history, pole reversals have been relatively common, happening 183 times in the last 83 million years. During a pole reversal, the magnetic field experiences a significant decrease in strength. However, Earth remains protected, as the magnetosphere collaborates with the planet's atmosphere to deflect the majority of harmful space energy before it reaches the surface. While some scientists have theorized that these reversals, accompanied by a weakening magnetic field, might lead to global climate shifts and extinctions, current data does not substantiate these assertions. Gavin Schmidt emphasizes, "There's no evidence that links magnetic changes to climate when we've seen big magnetic reversals or near reversals in the paleoclimate record. There's no climate change that goes with them. There's no mass extinction that goes with them." Kirk Johnson, the director of the Smithsonian's National Museum of Natural History, has dedicated a significant portion of his career to studying the extinction of the dinosaurs. In his examination of fossil records and timelines related to the Cretaceous-Paleogene boundary and the associated extinction event, Johnson focused on the magnetic reversal that occurred approximately 66.3 million years ago. According to Johnson, deep ocean sediment samples unveiled significant climate changes around the same period. However, this coincided with a massive volcanic eruption in India known as the Deccan volcanism, producing some of the longest lava flows on Earth. "We've always attributed that transition to the carbon dioxide released by the Deccan volcanism and the increase of greenhouse gases," states Johnson. "There's two things happening. The magnetic field is changing, the Deccan volcanism is happening, and there's climate warming. So that would be an example of coincidental climate change." He further emphasizes, "The cautionary tale there is that just because you have correlation doesn't mean you have causation."